Hello, my name is Max Strigup, and this is Physics Lab 4. In this lab, I perform this lab to observe how potential energy and kinetic energy are interrelated within a closed system, such as the mass spring system. I utilize the law of conservation of energy and the definitions of energy, force, and velocity in my lab, specifically gravitational potential energy, spring potential energy, and kinetic energy. And in this lab, I achieved near-perfect replication of harmonic spring motion. This accomplishment was possible due to my utilization of the law of conservation of energy. For this lab, I assumed that the law of conservation of energy applies to the oscillating spring mass system, and as a result of that there are no outside forces acting upon the spring mass system. Because of these previous two bullets, I also assume that the spring is performing unhindered harmonic motion, as there are no outside forces disrupting that harmonic motion, and that all measurements are accurate, meaning that the position values in both the x and y direction of the mass are accurate to the effect that the spring models perfect harmonic motion. For my procedure for this lab, I recorded the position values of the mass in Tracker across every single frame. This includes both the vertical and horizontal position values. The position values were based on the base point being the axis at which the spring is connected to a solid object, and the position was measured from that base point to the mass. I finally exported these position values into a spreadsheet and then accurately modeled oscillating harmonic motion within GlowScript. After doing this, I compared my recorded values of position with my predicted values of position, meaning I compared my tracker values with my GlowScript values. After this, if I noticed any discrepancies, I updated my work based on any errors until my tracker experiment was most similar to my GlowScript code. For my spring video and its associated graphs, as you can see here, this is what my view looked like while I was recording the values of the mass position in Tracker. The fixed point is demarcated by the crossing of the two pink lines, and the position of the mass is demarcated by the blue calibration line from the attachment point to the mass. On the right, you can see the two graphs of position across from mass, and this includes both x and y position, and below that you can see a table of x and y position across from time, which is unnecessary in this experiment but was still shown in Tracker. Here's my code for my physics animation, as well as the graphs for position over time and energy. As you can see in the position over time graphs for both x position and y position, my experiment, shown in red, closely matched the model, shown in blue, meaning that the experiment mimicked oscillating spring motion. In the energy graph on the bottom left, you can see that delta K, delta kinetic energy, delta potential gravitational energy, and delta potential spring energy oscillated throughout the entire experiment, whereas the total energy remained constant at 0 because this is a closed system. I learned from this experiment that with no outside forces present, the mass spring system mimics oscillating harmonic motion. This is based on the law of conservation of energy and it being satisfied by the mass spring system. The law of conservation of energy is satisfied by the system because no outside forces act upon the system for the duration of the experiment, thus making the energies equal to each other and no inputted work done on the system. Similarly, the periods of oscillation of the mass in both the x and the y direction are similar at 1.7 and 1.5 seconds respectively, because the mass is oscillating at a constant rate based on the principles of the law of conservation of energy.